To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapters, we discussed several things regarding to the density lesson. Within this chapter, like I said in the previous one, we'll be discussing mainly about the uses of hydrometers. So you know that the hydrometer can be used to measure the density of different liquids. So here we use this hydrometer thing to measure the density of different types of liquids. There are different types of measurements that we are going to take in different kinds of liquids. Especially these measurements are related with the density. So by using these density measurements, we can check the quality of those liquids. So hydrometers are used to get the density measurements of those particular liquids. So by that way, we can get the quality and other facts regarding those liquids. So now let's head on to see what are those special kinds of places and areas where we can receive these measurements related to density in order to check the quality of those substances. So first one is given. Cow's milk contain approximately 90% of water. Other than water, it contains lipids, protein, etc. Like you know that most of a substance, if you take any kind of a substance, organic means in the sense here, it's made up with plant or animal materials. So if you take organic materials, most of the times they contain water. So if you take cow's milk contain about 90% of water. The other percentage, the remaining 10%, is a collection of different substances like lipids, proteins, then vitamins and minerals and so on. Okay. So sometimes, my dear children, farmers, right, especially milk farmers, they take milk out from a cow and they add water, somewhat excess amount of water, in order to increase the volume. More volume means, you know that more milk volume means farmer can earn more money through it. So some farmers, they add more amount of water in order to increase the volume. However, my dear children, when you check the density of those substance, I mean like the milk, normal milk, and the milk which is added with water, the densities are going to differ. Density is going to change. Normal milk without mixing water has a greater density. You know that it usually contains 90% of water, no? So if more water is getting added externally to the cow's milk, then definitely this percentage would increase. Water percentage would increase. Increasing water percentage means, my dear children, the density is going to decrease. Because the percentage of solid substances contained within the material or substance or the cow's milk is going to decrease. So due to decrease in those solid content, definitely the density is getting decreased. My dear children, right? So density can be found out in normal milk and the given milk sample by the farmer. So by that way, the quality of the milk can be measured. Okay, quality of the milk can be measured. So here it is given, check, cow's milk contains approximately 90% of water. Other than water, it contains lipids, protein, etc. Because of the contribution of density of other constituents, density of milk is slightly higher than that of water. So as there are different other constituents like this, right? Protein, lipids, like lipids, proteins, and other substances. So these other constituents are like solid constituents. So therefore, my dear children, density of milk is somewhat higher than that of water, okay. So here it is given, amount of water in milk can be determined by the measuring the density of it using the hydrometer. This measurement can be used to decide whether water is added to the milk. Now, when you check the density of real milk, a good milk sample, with a sample received by another person or a farmer, we can check whether the water has been externally added with the milk or not. It's because the density is going to differ, right? When adding more water externally, definitely the density will reduce, right? Because we are not adding these solid compounds into the milk, but only water, okay? Hydrometers, which are specially made to measure the density of milk, are known as lactometers. Right? Lactometers. Special types of hydrometers which are specially designed to measure the density of milk is referred as lactometers. Lactometers, my dear children. Right then. The second use. Okay, let's see. Hydrometers are also used to measure the percentage of alcohol in alcoholic drinks like wine and beer. Those are known as alcohol meters. Now, to check the strength of, right, to check the strength of alcohol drinks, right, alcohol based drinks like wine and beer, you can use the, or not you actually, the industrially, the people who are making these things are using hydrometers. Okay, hydrometers are being used. By using hydrometers, the strength of the particular alcohol beverage can be found. Okay, certain type of alcoholic drinks, we have to measure the density. So by using the density, we can check how much is that particular alcohol beverage is strong, right? So the strength and the quality of the alcoholic beverage can be measured by using the density, my dear children. Then the next one. These alcoholic drinks also contain high percentage of water. Therefore, the density of alcoholic drinks are slightly different from density of water. So here it contains several, right? It contains some amount of water. So therefore, the density is somewhat different than the water, as it contains different substances. Okay, right. So this is the second use. We can measure the density of alcohol, right, alcohol based drinks, in order to check the strength of the alcohol drink and to find out the quality. Special hydrometers used to measure the percentage of alcohol in alcoholic drinks are called as alcohol meters. Okay, these things are called as alcohol meters. Right. Then the third use. The density of the acid changes according to the changes in lead acid batteries used in vehicles. Lead acid accumulators, or else lead acid batteries. In lead acid batteries, my dear children, lead is the main type of metal that we use, and it is displaced in acids. You know that even in the previous lesson we discussed that some metals are getting dissolved within the acids. So when dissolving these metals within the acid, the density of the acid is getting changed from time to time. When time passes, the density is going to change. As you know, when several substances are getting dissolved within a certain solution, the density is getting changed. Then by checking the density, my dear children, we can check the quality of the battery or the lead acid accumulator, right? We can decide whether the lifetime of the battery is going to be faded down, or whether the lifetime of the battery has been faded or not. Like up to which kind of, or what kind of a year we can use this battery. The lifetime period of the battery can also be predicted by using the density measurement, my dear children. Here the density of the acid is considered. The density of the acid is getting changed from time to time because of the dissolving process of lead within the acid. Okay. The condition of the batteries can be examined by measuring the density with a hydrometer. So the condition and the status of the battery can be checked or can be determined by the density of the liquid, my dear children. So here we use the hydrometer in order to measure the density. Right then, the next use. Soil hydrometer is used in determining composition of a soil sample. It can be concluded by dissolving a constant mass of soil in a constant volume of water to calculate the density of soil solution. So to measure the density and the components dissolved within the soil, my dear children, we can use the density. So here, to measure the density of a soil sample, we can dissolve soil. Okay, to measure the density of a soil sample, we can dissolve soil in water, in a unique water sample. Then we can measure the density of that particular solution. So by measuring the density of that particular soil solution, we can come into a conclusion of the regarding the composition of the soil. Okay, so to find out the composition of the soil and the quality of the soil, we use hydrometers. Here the particular soil sample is dissolved in water and the composition is being measured by using the density measurements, my dear children. Okay. Then the next one. Seawater contain high amount of salt dissolved in it. There is a special hydrometer called seawater hydrometer, right? Seawater hydrometer, special kind of a hydrometer that we use to measure the density of seawater. Okay, so seawater hydrometer is used to measure the density of seawater. Due to high concentration, the density of seawater is higher than normal fresh water. So I think you can remember where we discuss another special kind of a point regarding the Dead Sea. So over there I told you that when you take the Dead Sea, it contains high amount of salt. So because of having highest amount of salt, what will happen? The density of Dead Sea is very high, so that the Dead Sea can even float a human being without sinking in it. However, my dear children, the Dead Sea is not having any forms of life, animals especially, because of the high salinity. Okay, right. So the seawater hydrometer is used to find out the density of seawater, a special kind of a hydrometer, seawater hydrometer. Right. Then the next one. Composition of rubber is also measured by special hydrometer known as Metrolac. Composition of rubber, here it means rubber latex, my dear children. So rubber latex can be, the composition of the rubber latex can also be measured by using the hydrometers. Okay, here we use the special instrument called Metrolac in order to measure the density of rubber. Okay, so here rubber in the sense rubber latex. So density of the rubber latex can be measured by using the special hydrometer, which is referred as the Metrolac. So my dear children, these are the special uses of hydrometers. Okay, so what are those special uses once more? We can use hydrometers to measure the density of cow milk. By that way, we can check the quality of cow milk. Then the next one would be to measure the density of lead acid accumulators. By that way, we can check the quality and the condition of the battery. To get the soil samples, if you are given with a soil sample, to get the composition of a soil sample, we can dissolve the soil sample in water and we can measure the density. By that way, we can get the composition of the soil. Then to measure the density of alcohol, right? Alcohol based drinks like wine and beer. to check the strength of those things and to check the condition and the quality, we can measure the density. Then, my dear children, to measure the density of seawater, a special kind of a hydrometer used, which is referred as the seawater hydrometer. Then, to measure the density of rubber latex, and to find out the composition, we use the special hydrometer called Metrolac, and by using it, we can get the composition of rubber latex. Okay, so these are the ways, right? These are the ways, my dear children, or these are the special users of hydrometers. So there are different types of hydrometers in each and every instance. So these hydrometers are used in different instances to make or to measure the density and to get a certain idea about that particular solution. Especially we are checking about the quality and the condition of the particular liquid by using the hydrometer and by using the measurements related to density. Right then, so with that thing, my dear children, we have came to the end of our lesson part, the theory parts related to the density lesson. So let's see what are the things that we discuss once again within the summary. Okay, so first of all, we discussed that the density of a substance is the mass per unit volume, right? We discussed that density is the mass per unit volume in that substance. Okay, and we define the density by using a formula. So that formula is density equal mass over volume. So we even use the formula referred as rho equal m over v. Rho means the density, m is the mass, and v is the, right, v is the volume, right, v is the volume. So this is the special formula that we use to measure the density of liquids and also substances, to measure the density of substances. So rho is equal to m over v, or density equal mass over volume. The standard unit of density is kilogram per cubic meter. So kilogram per cubic meter is the standard unit, or else the SI unit. So it is given as kg m to the power -3. Density is a vital physical property of a substance. It differs from substance to substance. So we discussed that density is a very important quality in a substance. From one substance to another, this density factor is getting changed. So by that way, we can check the purity of those substances as well. Then the next one, hydrometer is used to measure the density of the liquid. We discussed that to measure the density of the liquid, we can use the instrument called hydrometer. So hydrometer made by thin glass tube. Underneath it, there is a bulb kind of an area. Within that, there are lead shots to make it somewhat heavier. So you need to dip the hydrometer in a particular liquid, so it will float. Then by that way, using the scale, we can measure it. That's how the hydrometer works. Then, my dear children, it is given density is a criteria to determine quality of liquids and solution. So like I said, under the users of hydrometers, we can use the density to measure the quality and the composition of a certain liquid. Okay, we can measure the density in order to check the quality and also the composition of a certain liquid. So these are the things that we have learned within this lesson part, my dear children. Okay, right then. So let's head on to observe our questions related to the lesson part. So first of all, my dear children, we'll be starting from the questions given in your textbook. So you are given with the first question, you have to choose the correct or most suitable answer. Here it is given number 1, international unit, the SI unit of density. So my dear children, it's pretty obvious, you know that the international standard unit or the SI unit of measuring density is kilograms per cubic meter. Kilograms per cubic meter is the answer then. So kg m to the power -3, it can be identified in here. 4 different liquids have equal masses of 8,000 kilograms each. The volumes of them are given below. A liquid 12 m to the power 3. B liquid 10 m to the power 3. Liquid C 8 m to the power 3. Liquid D 6 m to the power 3. The liquid that has the highest density. Right, my dear children. Now when you are given with this type of a question, I know that you are going for the calculations. You are going to calculate and find out how much is the answer for each and every value. Then you are selecting from those answers the one which has the least density. But however, by looking at these values, I can determine which one has the lowest density. Okay. Question is asking about the highest density. So I can determine which one has the lowest density and which one has the highest density. So if you take this liquid A, this one has the lowest density, the lowest one. Okay. I'll make a cross. This one has the lowest density. This one has the highest density. Let's calculate and see. So I'm going to show you the calculation as well. You know that density is equal to, okay, density is equal to, rho is equal to m over v. So in A, you can find it like this. A 12, then equal masses 8,000 kilogram, then the mass is constant 8,000. You divide it by 12 then. So here 4 times 3, 4 times 2, 2000 over 3. You divide and get the answer up to a nearest value. So 2000 you divide by 3. Then here 6, 18, for 20 again 6, 18, again 2, again 6, right? Again 6, right? So it's around 666. We'll just keep as a simple value, right? Just a value like this. We'll keep it like this. It's very easy. Then B, once again the same, you have to divide what by what? 8,000 by how much? 10. It's very simple. 800 is the answer. Then C, in C, you have to divide 8,000 by how much? In C, 8,000 by 8. So 8,000 by 8 is equal to 1,000, right? Then final one, D. Here you need to divide 8,000 by 6. 8,000 by 6. We'll take a near value, okay? So here it's 3 and here it's 4. So 4,000 over 3. Here 1, 3, 1 for 10, 3, 9, 1 for 10 again, 3, again 9, again 1 for 10 again, 3. 1,333. See, I think my one is correct, right? A has the lowest 666. D has the highest 1,333. Now, without calculating, how did I took the answer? That was the question, right? So, let me explain once more. Density equal mass over volume. When increasing the mass, density also increases. It's because mass and density have a common, or else we refer that thing as a direct relationship, right? Direct means when increase in mass, density also increases. When decrease in mass, density also decreases. Okay, so mass and density shows a direct relationship. Okay, my dear children. Then the next one, volume. What happens when increasing the denominator in a fraction like this? When increasing the denominator in a fraction, my dear children, the value after the division is going to decrease, or it has a very low amount of value. Imagine like this. You have a cake and you need to divide that cake into 8 pieces. That's what do you mean by 1 over 8. Now from that 8 pieces, you are going to eat 1. That's what do you mean by 1 over 8. From the same cake, okay, if you are given with the same cake like that, and you here at this time you need to divide it into only 2 pieces, that means you are giving it to only one friend. In that case, you will be receiving more amount of cake than the previous instance. So that means in a fraction, when increasing the denominator, or else when the division 1 is, or the denominator is higher, the value or the amount received is going to decrease. Higher the denominator, lesser the value obtained. Okay, that means, my dear children, density and volume has an inverse relationship. An inverse relationship. Higher the volume, lower the density. Lower the volume, higher the density. So this question is really simple. This question is really simple if you know those stuff, right? If you know those things, then this question would be really simple. Why is that? Now I told you the relationship between mass and the density. Then I told you about the relationship between volume and the density. So by looking at these things, my dear children, you can just get the answer without the calculation. How come? Because, my dear children, here the mass of the substance is constant, it's not changing. The liquid A has the highest value of volume. That means it has the lowest density. Higher the volume, like I said, higher the volume, lower the density. Those things are showing opposite relationship or else an inverse relationship, right? So our answer would be for the question number 2. Here they are asking about the liquid that has highest density. So go for the one which has the lowest volume. Answer is D. D is the answer for the highest denser one. Right. Consider the following statement on the density of a liquid. Density of a liquid depends on its mass. Density of a liquid depends on its mass. It is correct. Density of a liquid depends on its volume. Once again, correct. Density of a liquid depends on the kind of the liquid. Incorrect. This is incorrect, right? It's not depend on the kind of the volume, kind of the liquid, right? Actually, kind means it's depending on the particular type of liquid because of changing mass and the volume. Right. So the true statements out of these things are, it's very obvious, A and B only. Always remember, density of a liquid depends on 2 different factors. Number 1, its mass. Number 2, the volume. That's why the formula is given as mass over volume. Next one. 4 different liquids have equal volumes of 0.5. Masses of these liquids are given below: 400, 550, 500, 600. The liquid that has the lowest density, my dear children. Now let's I think you could remember in the second question, I told you that density and mass are directly proportional or direct connected to each other. When increasing the density, the mass also increases. When decreasing the density, mass also decreases. So go for the answer go for the answer that has a lowest mass, because it is asking about the lowest density. So go for the answer that has a lowest mass. So the lowest mass is 400, right? So the answer would be P. P is our answer, right? Here the volume is a constant value, right? Volume is a constant value. So go for the answer that has a lowest amount of mass. Lowest amount of mass can be observed within P, my dear children. So P is our answer. Figure given below shows 4 liquids that have equal masses kept in equal containers. Right. Figure given below shows 4 liquids that have equal masses. So they have equal masses. Equal masses. So as you can see here, even though they have equal masses, their volumes are different. Their volumes are different. Let's take several imaginary values like this. We'll imagine that here it is 250 milliliters. Then over there at M, it's around 200. Somewhat lesser than this thing, no? Then over here, it's around 100 milliliters, right? Somewhat imaginary values. We don't know whether these things are correct. But however, by looking at the levels, definitely we know that if it is 250 here, then somewhat lesser than that, like 200. Then over here, somewhat even lesser than that, like 100. Then in here, the lowest one, like 50. So these are some imaginary values. We don't know whether these answers are correct or not. Okay. So I have taken their volumes like this, imaginary values. Now you know, my dear children, right? Now you know, as they have equal masses, when you divide these masses by these given volumes, you can directly find out the density. In the second question, I told you that volume of a substance and the density is having an inverse relationship. So the one which has the lowest volume has the highest density. One which has the highest volume has the lowest density. So let's go for the answers. Select the correct answer which illustrates the ascending order of densities of 4 liquids. Ascending order. Ascending means from lowest one to highest one. If you need to find out the lowest one to highest one, right, the densities, then we can do it like this. So first of all, we need to check the lowest one, the lowest density. So the lowest density can be observed in K. This is the lowest one, K. Then after K, the second lowest one would be this thing, 200 milliliters. So it is M. Then after M, L. Finally, N. So K is the one which has the lowest one. Then somewhat greater in M. Again somewhat greater in L. Highest is in N. So select that order from these things. K, M, L, N. So second one is our answer. K, M, L, N. Right? K, M, L, N. So this is the volume, my dear children. Right? This is the relationship between volume and the density. Always remember, volume and density is having an inverse relationship. Higher the density, lower the volume. Lower the density, higher the volume. Okay. So here this one is having 250. So it has a lower volume. It has a lower density as it is having high volume. This one has low volume, therefore high density. Right. So when you arrange it in ascending order, the answer would be K, M, L and N. Right. Next one. Figure below shows 4 equal hydrometers floating in 4 different types of liquids. 4 different types of liquids, 4 equal hydrometers. Out of those, the liquid has the highest density. If it is having the highest density, then the amount, the floating part should have a greater value or greater amount, or else the sinking part of the hydrometer should be very less. Okay, so sinking part is very less in this thing, so the answer would be U. U is the answer, right? T has the lowest density because more amount has sunk within the liquid, my dear children. More amount of the hydrometer has sunk within the liquid. Okay, so U is the answer. U has the highest density, T has the lowest density. The question is asking about the highest density one, no. So this one has the highest density. Always remember, when you dip a hydrometer, right, when you dip a hydrometer, if more amount of, if greater part is floating, then it has the greater density. Or else, if a greater part is sinking, then it has a lower density. If a greater part is sinking, then it has a lower density. Okay, right. So these are the answers for the MCQ questions, my dear children. Right, then the second question. Observation received while preparing an orange solution is given below. Orange seeds which were at the bottom of glass started floating when adding sugar. Give reasons for this observation. Now, right, when something, in order to sink something, can you remember the process that occurred within the hydrometer? I think you have. If the liquid has a higher density, then the amount of the hydrometer which is going to sink is going to reduce. Less amount is sinking, more amount is floating. If the density is high in a liquid. That means, my dear children, right, now check about the Dead Sea. Remember about the Dead Sea. More amount of salt is dissolved within Dead Sea. So therefore the density is very high. If the density is high, people even can float within the Dead Sea without sinking. It's because density of the water is very high. So when the density is very high, objects will definitely float on that particular liquid. That's the basic idea. Okay. So here it is given at the stage where the sugar haven't been dissolved within this, right? It's like this. Orange seeds are at the bottom. But after dissolving sugar, right? After dissolving sugar, it says that this thing happened. Seeds came somewhat up like this. Earlier, it was at the bottom. It was shrinking very well. After dissolving sugar, right? After adding sugar, it is like this. More amount is floating. If more amount is floating, in here the density is high. In here the density is low. Compared to what? Compared to the orange seeds present within the solution. That means, my dear children, it's very obvious to us that upon dissolving sugar within the orange juice, the density of orange juice is going to increase than the initial amount. So therefore, orange seeds will easily float on the solution. That is our observation and the conclusion. This is the explanation for the answer there. So reason is very simple. We can write when adding sugar, density of the liquid or the solution gradually when adding sugar, density of the liquid or the solution gradually increase. Therefore, seeds will float. Right. So when adding sugar, density of the liquid or the solution gradually increases. Therefore, seeds are floating. Right? That is the reason. That is the reason why the orange seeds are getting floating on the orange juice after adding sugar. Right? So here, low density. But in here, high density. Right. So low density in solution, then over there, high density in solution. This what happens after adding sugar, my dear children. So when adding sugar, density of the liquid or the solution gradually increases. Therefore, seeds are floating. This is our answer. Okay. Right then. So here, it's like H. So I'll mention once more. Therefore, seeds are floating. Right. Now the answer is perfect. In the earlier it was like H, so you might get confused with H, so that's why I corrected it. Okay. Right then the next one. Calculate the density of 4 cubic meters of volume of liquid with 3600 kilograms mass. Very simple, my dear children. You know that density is equal to mass over volume, right? Density is equal to mass over volume, rho equal to m over v. Then mass is given how much? 3600 kilograms. Division 4 cubic meters. You can cut this thing, here 1, here 9. So our answer is 900 kg m to the power negative 3. 900 kilograms per cubic meter. Next one, density of a solution is 2000 kilograms per cubic meter. Calculate the mass of 0.25 cubic meters volume of this solution. So you need to find out the mass of 0.25 cubic meters. Okay, you need to find out the mass of 0.25 cubic meters. Once again, we'll apply the formula density or rho is equal to mass over volume. Density equal mass over volume. So density is given. Here the density is given, my dear children. Density equal to 2000. Right? Mass is the one we are going to find out. So M is not given. However, we do know the volume. Volume is given as 0.25 cubic meters. Now, once again, what you have to do, you put 1 here and do the cross multiplication. So, after doing the cross multiplication, you can get the answer 0.25 into 2000. 1 into M, it is equal to M. 0.25 m to the power 3 into 2000 kg m to the power negative 3. So, m to the power 3 to m to the power negative 3 is getting cancelled. So, from kilograms, you will get the answer for the mass. 0.25 means, my dear children, it is equal to 25 over 100, right? 0.25, 25 over 100. You can turn it into a fraction. This is 2000. 2 zeros to 2 zeros are getting cancelled now. 20 times 25 is equal to 500 kilograms. This is our answer, right? 25 times 2 is equal to 50. Then you put the 0 which has ignored to here. So our answer would be 500 kilograms. 500 kilograms. This is the mass of 0.25 cubic meters of volume that has a density of 2000 kilograms per cubic meter. Right then, the next one. So my dear children, with that we have finished all the questions related to the textbook. Now it's time to discuss several extra questions. So first of all, you are given with MCQ type questions here. So the question number 1, density is mass of unit volume, force in a unit volume, weight of an object in unit volume, force acting on unit area of an object. So you know that it's very simple. Density is the mass of unit volume. So answer would be mass of unit volume. Mass of unit volume, right? Mass of unit volume is the density, my dear children. Next one. The international standard unit of measure in volume. Asking about the volume, my dear children, okay? Number 1, square meters. No, not a square meters. Cubic meters, yes, that is the answer. Cubic meters is the international standard unit of measure in volume. Not cubic centimeters, it is a secondary unit, right? So, cubic meters is the correct answer. Cubic meters. Next one. Carrot slice sinks in liquid A and floats in liquid B. Which liquid is more dense? So, sinks in A, floats in B. So, which one has the more density? More dense means high density. So, my dear children, if a certain thing is floating in a certain liquid, then the liquid has a higher density. If a certain thing is going to sink within a liquid, then that particular liquid has low density. So here it is saying that carrot slice sinks in A. That means this one has low density. Floats in B, therefore this has high density. So the question is asking which one has the high density. So more density can be observed in B, high. B. Number 4, whether or not an object floats in water will depend upon. Whether or not an object floats in water will depend upon density and width, volume and color, area and mass, mass and volume. Whether or not an object floats in water will depend upon. It depends upon density of that particular liquid. Density is measured by using the mass and the volume. So my dear children, whether or not an object floats in water will depend upon the mass and the volume of the substance, right? Mass and the volume, both, okay? Because sinking or floating depends on the density. Density depends on mass and volume. Here the first one is incorrect as it is given as the width. Width is not relevant, right? So the correct answer would be mass and the volume. Right. Then this is the answer. D is the answer for the question number 4. Now let's head on to see the question number 5. Density is mass per unit, weight, area, length. The correct one would be volume. Density is the mass per unit volume, right? It is the mass per unit volume. Next one. A block of ash wood has a mass of 1 kilogram and occupies a volume of 0.00125 cubic meters. What is its density? So, block of ash wood has mass of 1 kilogram, occupies a volume of 0.00125. So, you need to find out the density. Let's apply the formula. Density equal mass over volume. Mass is equal to 1 kg, 1. Then the volume is equal to 0.00125. So here 1, 2, 3, 4, 5, there are 5. So as there are 5 decimal places, I'm going to multiply this thing by 10 to the power 5. You know that you can write this thing by using the scientific notation, right? This number, when you are converting that thing into a whole number, you can write it as a scientific notation, right? So here 1, 2, 3, 4, 5, there are 5 decimal places. That means you need to multiply it by 100,000. 100,000 is equal to 10 to the power 5 in scientific notation. So here, once again, 10 to the power 5, then it is equal to 100,000 over 125. 100,000 over 125. So this is pretty obvious, my dear children. You know that in here, for 100, there are 4 25s. And for 125, there are 5 25s. Then here, 4 and 0 means 40. You can cut again. Here 1. For 40, there is 8. So 800, answer is 800. Go for the answer 800. Yes, 800 can be observed here. So the answer is 800 kilograms per cubic meter. 800 kilograms per cubic meter. (800 kilograms per cubic meter), right? This is the answer. Question number 7. Which of the following substances is the least dense? Least dense, okay? Water, iron, wood, oxygen gas. Very obvious question. The question is asking about the least denser one. Least denser one is very simple, my dear children, oxygen gas. Like I said, the densities of gases we cannot measure that thing that much smaller, right? Because gases are going to spread here and there. So therefore, it has very less density, very less denser, right? Next one. Which of the following substances is the most dense? Most dense. water, gold, air and wood. So if a certain thing has a greater density, my dear children, the particle arrangement would be somewhat tighter. They have tight particle arrangements, because if the particle arrangement is somewhat tighter, then more particles can be observed within unit volume. That means they will have a high density. So to have a high density, the particle arrangement should be tighter, right? So most of the times solids have very high densities. Solids have very high densities, as the particle arrangement is somewhat tighter than liquids and gas particles. So if you are being asked to find out, right, if you are being asked to find out densities with higher or greater ones, go if the question is asking about the higher density, go for an answer that has tighter arrangement of particles. That means simply solids. If you have been asked to find out least denser ones, then go for the answer that has a least combination between the number of between the particles. Okay. So here the question is asking which one of the following substances is most dense. So the most dense one would be gold, right? Most dense one would be the gold. Right then. Why does an iceberg float on water? The iceberg is lighter. Density of the iceberg is greater than that of air, that of water, right? Yes, that of water. Density of iceberg is greater than that of water. Density of iceberg is less than that of water. The iceberg has less volume. Why does an iceberg float on water? What is the reason? Iceberg means a glacier. No matter the size of the glacier or no matter the size of the iceberg, each and every iceberg is going to float on water. It's mainly because the density of iceberg or the density of water is greater. Density of water is greater than the iceberg. That is why the iceberg is floating in water. I told you that if a certain liquid has a higher density, then the substances will easily float. If a solution or else a liquid has a lower density, then the substances will easily sink. If an iceberg is floating in water, that means water has high density. That means iceberg has a lesser density. So compared to the water, density of the iceberg is less than water. That is why the iceberg is going to float on water, my dear children. The density of the iceberg is less than that of water. So therefore, iceberg float on water. Next one. Which substance has the highest density out of the given? Which one has the highest out of the given ones? Highest ones. Water, liquor, mercury, aluminium. Water, liquor, mercury, aluminium. You know that water, liquor, these two have least densities. I think you can remember. Density of liquor is something around 700, 800, right? Greater than 700, less than 800, something around that, right? Density of liquor. Density of water, we found out that thing even from the calculations, it is near to 1000. Nearly it is 1000. We don't know about the density of mercury and aluminium. We know about something, we know something about the density of mercury. Actually, the density of mercury is something around 13,000 something, right? 13,000 something. But however, aluminium was not there. So I gave you a condition that if you need to find out more denser ones, go for the answers that are in the solid state. So in here, you would definitely go for the solid state answer. But however, my dear children, it is incorrect. Here, the most densest one is mercury. Most densest one is not aluminium. Here it is mercury. Aluminium has a lesser density than mercury. Okay, aluminium has a less density than mercury, my dear children. So mercury is the one which has the highest density. Okay, mercury is the one which has highest density over here. Density of mercury is actually in value, it is equal to 13,600 kilograms per cubic meter. 13,600 kilograms per cubic meter. Okay. But however, my dear children, if you take the density of aluminium, it is something around 2,700, something around 2,700, to be in an exact 2,710 kilograms per cubic meter. Both of these things are metals. You know that mercury is a metal, right? Both of these things are metals, but however, mercury has the highest density, even though it is in the liquid state. Okay, somewhat new thing to your knowledge then. Right. Which of the following metals will sink in a basin of mercury whose density is 13.6 grams per cubic centimeter? So the density is given here. Density of mercury is given 13.6 grams per cubic centimeter. 13,600 kilograms per cubic meter, 13.6 for a cubic centimeter. Right. So the question is asking which one will sink. In order to sink, the material should have a greater density than the liquid. Liquid should have a lesser density. Material should have a higher density. So go for the one which has a high density in the material. So here 7.9 incorrect. Here 2.7 once again incorrect. Here 11.3 compared to 13.6, 11.3 is also less, therefore incorrect. Then our answer would be uranium of density 19.5 grams per cubic centimeter. 19.5 because it is greater than the density given over here. So if the density is greater, definitely those substances will sink. If the density is lesser, definitely those substances will float. Okay. Denser substances go to the bottom. Lighter substances go up. When you jump into water, you go down because your density is lesser. Density is greater than water. Water has the lesser density. Okay. That's normal pure water. When you jump into water, definitely you will drown or else you will sink. It's mainly because your density is greater than the density of water. So denser substances always go down. Denser substances always go down. Lighter substances always go up. Lighter means less density. Okay. Right then. So the next question. Which one of the following conditions will cause the density of water to increase? Density to increase. Okay. Density to increase. Density to increase. So in order to increase density, you have to increase the volume. Or else you have to decrease the volume, not to increase, right? Not to increase, but you have to decrease the volume. If you increase the volume, I told you that density and volume has inverse relationship. So as they are having inverse relationship, if you increase the volume, then what will happen? The density would decrease. However, you can increase the mass. You can increase the mass of water, no problem. Or else you can decrease the volume of water. Okay. Both the things are given no. Increase in volume, increase in volume. So it is incorrect. You have to decrease no. Increase in mass. So this is correct. Increase in mass would definitely increase the density of water. Dissolving substances add in more water. The thing is that, my dear children, if you take the density or else if you take sample of water, how can you increase the mass of water? Is there any possibility? In order to increase the mass of water, you have to add more water. So when adding more water, density never going to change, right? Can you remember the activity? We took 100 milliliters, 250 milliliters, 500 milliliters. Even though the volume is getting increased, mass upon volume ratio is a constant, 0.99, the value which we took from the activity. That means, my dear children, we won't be able to increase the mass of water without adding more water. So increasing mass is not a probable answer. Adding more water is also not a probable answer. But however, there is one certain way to increase the mass of water without change in the particular volume. How can? You can dissolve a certain substance like salt or sugar or any kind of a solid. When you are dissolving it, volume, we assume that the volume is not going to change, right? However, the substances are getting dissolved. So my dear children, definitely what will happen? The density would increase. So the density can be increased in water by dissolving substances. We won't be able to change volume or mass without adding water or without reducing water. Okay. However, that would definitely not change the density, because always mass over volume ratio is a constant. That is what do you mean by the density, right? Alright then. Which of the following gas is the least dense? So like I said, if it is having a least density, then those gases are going up. If the gas is having a higher density, then those gases are coming down. Can you remember when we are discussing about the hydrogen and oxygen gases? I think you can remember we discussed that hydrogen is a very light gas. Light gas means it has a lower density. So, which one of the following gas is the least dense? Least denser one is hydrogen. Right? Least denser one is, my dear children, hydrogen gas. That's why hydrogen gas is used to fill air balloons or weather balloons. Balloons will definitely go up with hydrogen as it is having a lesser density. Right. Olive oil is a liquid whose density is 0.92 grams per cubic centimeter. Olive oil and water are placed in a beaker. Which of these liquids will float on top? You know that density of water is equal to 1000 kg m-3 or else 1 gcm-3. 1 gcm-3 means 1 gram per cubic centimeter or else 1000 kilograms per cubic meter. So when you compare these two, my dear children, olive oil has a lower density, water has a higher density. If the density is high, those things will go to the bottom. Then the floating one would be olive oil. So water, incorrect, neither, they are mixed together. Once again incorrect, these things are not getting mixed. So our correct answer would be olive oil. Olive oil is the one, right? Olive oil is the one which is going to float on top. Okay. That is the one which is going to float on top because it has a lower density. Question number 15. ABC shows 3 liquids in a vessel. Which one has the highest density? Once again, it's obvious, my dear children. I told you, densest one, go to the bottom. Lightest one goes up. Least denser ones goes up. High denser ones goes down. So select the one which is at the down. C is at the down. So out of A, B, C, which one has the highest density? C has the highest density because it is at the bottom. Next one. Which one has the lowest density? A should be the answer because A is at the top. A is at the top. C is at the bottom. Okay. Right. If volume is equal to V, D is the density, capital M is the mass of an object, then which of the following relationships is correct? So D equal M times V, incorrect. D equal M division V, this is correct. This is correct. D equal M times V, M times D plus M times V, once again incorrect. D equal V division M, interchanged, right? Incorrect. So the correct answer would be D equal M division V. Next one. What is the instrument used to measure the density of a liquid? Very simple, my dear children. To measure the density of a certain liquid, we use the instrument called the hydrometer. So go for the answer that has the hydrometer. Yes, hydrometer is here. So hydrometer is the instrument, my dear children. Hydrometer is the instrument that we use to measure the density of a certain liquid. So hydrometer, triple V imbalance, we use it to measure the mass, same as the chemical balance. The barometer is used to measure the atmospheric pressure. So you will be learning about this barometer in the next grade, my dear children, under the 15th lesson. Okay. So till now you just remember barometers are used to measure the atmospheric pressure. Okay. Right. So this is the question number 18. 19th question. An object is most likely to sink in water. Object is most likely to sink in water. Sink means going down, right? Sink. So going down means it should have high density. So it's very obvious. It has high density. It has low density. It has high density than water. It has low density than water. Actually, it should have a high density. But however, here you have to choose the most accurate answer, no? In that case, my dear children, if a certain object is sinking in water, then we can say that the density of that particular material or the object is greater than that of water. That's why it is going down in water. So our correct, most accurate answer would be it has high density than water. It has high density than water. That's the most accurate answer. Next one. Two liquids A and B have densities 0.75 grams per milliliter and 1.4 grams per milliliter respectively. When both liquids are poured into a container, which liquid floats on top? Once again, a same kind of a question like the previous, right? The two densities are given 0.75 grams per milliliter and 1.14 grams per milliliter. You know that 1 milliliter is equal to 1 cubic centimeter. So here the density is given by grams per cubic centimeter. So here 0.75 grams per cubic centimeter, and over there it's equal to 1.14 grams per cubic centimeter. So out of these two, right, B has the highest density, A has the lowest density. So the question is asking which liquid floats on top. So go for the answer which has the lowest density, because low density ones are floating or else going up. High density ones are sinking, going down. So A has 0.75, B has 1.14. So which liquid will float? The liquid that is going to float is this A, as it is having a lesser density. Okay. Right, my dear children. So we have discussed 20 MCQ questions, extra questions related to the lesson. In the next chapter, I'll be discussing even more questions related to the lesson, my dear children, right? So we'll discuss several MCQ questions and several other extra essay type questions in our next chapter. Okay. So I'm going to wind up this chapter, my dear children. Within our next chapter, we'll continue the other questions from the density lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.